Hi, welcome back. So far in this course, our Arduino has been capable of communicating only with its host computer. And that communication was very limited. Upload the sketch from the host computer to the Arduino and send text messages from the Arduino to the computer via the USB serial interface. We would like to do much more with communications, and in this lecture I'll show you how to get your Arduino gadget to speak to the internet. There are several ways to make this work. In this lecture we will look at the Ethernet shield, which represents the easiest and very capable still method. There are also Wi-Fi, which is technically very similar to Ethernet but wireless. I will leave Wi-Fi aside for another time. Ethernet is the most common local area network technology around. You probably have an Ethernet device in your home connecting your computers, printers, storage servers, etc. together and to the internet via a router. The easiest way to add Ethernet capability to your Arduino is via the Ethernet shield. When this shield was added to the Arduino's product lineup, it opened up a world of possibilities. Your project could now be connected to the internet and be part of the Internet of Things, an internet where devices are represented as virtual objects with which people or other objects can interact. For example, your internet-connected fridge could report its temperature and alert you in case of malfunction, or your garden watering system could log the soil humidity levels to an online logging service like Nimbits. I'm going to have another lecture where I'm going to show you how to do logging on Nimbits later on. I personally find the Internet of Things a fascinating concept, and people come up with all sorts of applications to show what is possible to do in this universe. I have a link with examples of what people do on the Internet of Things in the lecture notes. In the first demo, I'll show you how to connect your Ethernet shield and how to make your Arduino as a part of your local area network. Specifically, I'll show you how to connect to the network automatically by acquiring an IP address via DHCP, or how to acquire an IP address manually. For each connection, your Arduino will report the connection attributes in the console. You'll need the Arduino Uno and an Arduino Ethernet shield. Okay, I'm going to show you now how to connect your Ethernet shield onto your Arduino and then configure it so that it becomes part of your LAN. Let's have a quick look at the shield itself first. So what we have here is a shield with that attaches directly onto the Arduino and onto its headers, and of course we've got the J45 jack here and then the WISNet Ethernet controller. Once you plug it into the headers of your Arduino Uno, the thing to notice is that communication between the Ethernet shield and the Arduino is happening via 4 pins. So you have digital pins 10, 11, 12 and 13 that are utilized by the Ethernet shield, and it talks to the Arduino using the SPI bus, which is a serial bus about which I'm going to have a dedicated lecture later on. There's quite a few things to talk about the SPI bus, but the thing to remember for now is that because these 4 pins 10 to 13 are engaged for Ethernet communications, you can only use the rest, but I think that's quite sufficient for most users at least. Now, another thing to remember is that of course this is a quite large device. If you want to go past the prototyping stage and have your project deployed in its own package, you may want to use something smaller for your Ethernet needs. So what you can do in that case is to get one of these. It's essentially the same thing in a much smaller PCB. It only has the absolute minimum to get your Ethernet connection and connectivity going. It's got the same chip or a variation of the same chip, same speed. You can use it with the same Arduino library that I'm going to show you in a minute. That's what I do if I want to deploy a project. Another nice thing about this Ethernet shield is that it's got an SD card slot, so you can plug in your mini SD cards in this slot, and on these cards you can have files, like image files, for example, that you want to make available to a web server that is running on the Arduino. Or you can use it for logging purposes. So if you've got some sensors attached to your project and you want to, every few seconds, every few minutes, take measurements, store them onto the SD card, and then every couple of hours, perhaps, your Arduino can use its Ethernet connection to send the data out to a logging server. And speaking of logging servers, I have a lecture later on, I think it's going to be lecture 37 at this point, in which I'm going to show you how to use an external web-based or cloud-based logging service for your project. So back to this, and once you have it plugged in, there's nothing else to do. You're good to go. Plug in your Ethernet cable going to your router, or perhaps via a switch, and plug the Arduino into your computer. Now for the first sketch, I'm going to use one of the built-in examples. I'm going to go to File, Examples, Ethernet, and bring up the DHCP chat server. So I'll go through the sketch really quickly before I upload it to the Arduino, because there's actually a couple of things that I need to change here before I can deploy it. So the first thing to notice is that we need to include the SPI library, so the serial interface that the Ethernet controller on the shield is using. So I'm going to include that first, and then I'm going to include the Ethernet library. Now the Ethernet library is really well documented. So if you go to the Arduino website, go through reference, libraries, scroll down, and you'll see the Ethernet library here. It's quite substantial. So it gives you a bit of background documentation. For example, it lets you know which pins are engaged so that you avoid using them for other devices. We are playing with the Arduino Uno, so we're going to be on pins 11, 12, and 13. And it also makes a mention that pin number 10 is used as SS, which means slave select pin. Because the SPI is a bus serial interface, it means that you can have multiple devices connected on the same pins, communication pins, which are 11, 12, and 13. And in order for your sketch and the Arduino to be able to switch from one connected slave device to the other, it uses a select pin. So for the Ethernet shield, that is 10. And also remember that this Ethernet shield also has an SD card adapter on the PCB. So if you want to do any reading or writing from the SD card, then you need to also use digital pin 4 as the SS pin, the slave select pin for the SD card. Again, I've got another lecture to show you how to use the SD card coming up. Another thing to notice, just going through this library, is that you've got a number of classes in here. Of course, you've got the Ethernet class, which we are going to be using the begin function of in the sketch that we're going to play with in a minute. There's also a server class documented here, which allows you to build a server which sits there listening for connections from clients. And there's also the client class here that we are going to use if we want to work with things such as a telnet client that we'll be doing in this example, or in the next lecture, I'm going to show you how to build a web server which will be responding to a web client, like a web browser. So we'll be modeling those types of clients using the client class that comes with this Ethernet library. Okay, that's all for now. Now, back to our example sketch. The first thing to see is that there's a bit of configuration that needs to be done first. We want to make this device to become part of a local area network, and to do that we need to tell the device, or to the sketch, what is going to be our hardware address. So this is the Ethernet protocol requires that any host has a hardware MAC address specified. Usually, depending on the Ethernet adapter, these addresses are hardwired onto the controller itself. But with the Arduino, typically you'll find a sticker either on the PCB device or the box, the packaging in which the Ethernet shield comes in, and it'll have a number like this. So if you do have such a sticker, or perhaps a leaflet inside the packaging, just copy whatever values you have on that sticker in this array of bytes. I unfortunately lost mine a long time ago, so because I only have one Arduino at this very moment running in my network, it's highly unlikely that there's going to be any other device with the same MAC address. So I'm pretty confident that this is going to work. I'm going to leave it aside. I could just make a little change if I want to be super safe about this, and just make a little change here and just differentiate the MAC address that I'm going to assign to my device. The second thing is the IP address. So we will want to connect to the internet, or we will want to be able to access our Ethernet device via some kind of internet service, like in our case it's going to be Telnet. To do that, again, we need to have an IP address that is unique in our network. In this example, we will be using a service called DHCP, which automatically assigns an IP address and provides the appropriate settings to a device that is asking for such information from the DHCP server. But in case a DHCP server is not available in your network, what you do is that you just provide a fallback IP address. So in my case, because I know that my network is at this subnet 192.168.1.1.1, I'm just going to change the third number, which was 1 in the default sketch, to 1.1.1 to match my own LAN and the subnet that I have configured my own LAN. In your case, it could be just 1, but you're going to have to check that. Now, an easy way to check that, if you are on the Mac, is to have a look at your preferences, your system preferences. So you bring up system preferences and then you check network. And you can see that in my case, the IP address of my computer is this. This first part, first 3 digits, make up the LAN address. So the subnet is 192.168.1.1.1, and the last digit is the host address. So this is the IP address, the address of my computer. And another thing to notice is this number, 111.1. In my case, is the router, and it's also the gateway address, which again I'm going to use in my Ethernet configuration for my Arduino. So on Macs and on Windows and Linux, there's a slightly different process for getting those that information about your subnet and your gateway. But I'm going to have notes in the PDF file that comes with this lecture to help you out with this. If you are having trouble, just ask me as well. So I'm going to use .177 177 as my fallback IP address for this Arduino. I need to also fix the gateway. So the gateway is a special computer or device that the Arduino will be using if it needs to talk to a service or a web server on the internet. So I'm going to switch that to 111,1 since I know that that is the gateway plus router in my network. And finally, I'm on a class C network, not class B as the default example here. So I'm going to change the 0 in the third digit into a 255. If you're not sure what a class B, class A, class C network is, don't worry too much about it. If you're running these examples in your home network, then 99.99% of all cases, you will need to have a subnet mask to match the one in this example, 255,255,255,0. That's called the class C address, which is very common for home networks. Okay, that's all the configuration that I need to do. So a couple of other things to notice here before I execute this example. Here we instantiate the Ethernet server. So we're setting up a server that will be listening to port 23. So port 23 is a default port for telnet services. If you're running a web server, you change that to port 80, or if you're running a SSH server, I believe that would have been port 22 or something like that from memory. So we set that up here. Now this server is going to be sitting in the background listening for connections. I've got a boolean, got a message, true or false, the two values that it can take, that we're going to be using to let the part of the script know whether there is a new message or a new character that has been transmitted to our server from a connected client. You'll see how that works in a minute. Then setup is pretty typical. We start up a serial interface so that we can get some output into the IDE console. Then what happens, the next important thing that happens is that we are trying to now start the Ethernet service on the Arduino, and we use the begin function and we pass the MAC address that we specified earlier. Now this is going to go and try and contact a DHCP server on our network, and the DHCP server is going to come back saying here's some credentials, or here's some information that you can use to connect. There's the IP address and subnet mask and a gateway. These are the basics that you need. But if it doesn't, if a DHCP server cannot be connected to, or the DHCP server does not return any useful information, then it's going to return a 0 value. So if that happens, we're just going to go back to our fallback values and start the Ethernet service anyway with whatever information we provided earlier in the configuration segment. So we're going to use a default IP address, gateway, and subnet. And that way at least we can get started. It's unlikely that in your network you're going to have this problem, because these days most routers by default run a DHCP server. So one way or another, the Ethernet service is going to begin, and it's going to print out the IP address that it was assigned to it using this block. So the local IP function returns an array of bytes, and that's how the IP address and the 4 bytes of the IP address are encoded in that value that local IP function returns. So we're going to go through these 4 bytes in this array and print them out. And this is something we haven't seen before. It's just a normal print function that we have seen earlier, but this time we are taking a byte as input we are converting it to a decimal, and then we're printing out the value so that we can see a decimal instead of a byte value coming out to the monitor. And finally, we start the server. We get into the loop function. The loop function, we constantly check to see if there is a client that is trying to connect. I'm going to show you how a client will connect to this script, to this sketch in a minute. But if there is a client that is trying to connect, then we are going to capture that into the client object, which is of Ethernet client class. So if this is the first time that a client connects to us, then got message has already been defined as false. So if this is the first time that a client is connected, then we'll let the user know by printing out a message. We also send the same message to the client's telnet console to greet them. And we change the boolean got a message to true. Now, telnet is a serial type of communication, so it will be sending us messages or the words one character at a time. So we'll be grabbing one character at a time and putting it into a local char variable. We're just going to bounce that out to the client's telnet console and to the serial interface, the IDE console. So basically, whatever they are sending to the server, they will be getting back to the console. Okay, so let's upload that sketch and see it in action. Okay, bring up the monitor. So you can see that although we specified an IP address to be 111.177, the local DHCP server actually assigned or leased an IP address that is 111.64. So I'm going to put it aside and bring up the console. Let's try to connect. So telnet 192.168.111.64. Hello client, I have connected. So anything I type now comes back twice. Here I type the letter D once. This is the one that I typed, and the second occurrence of the D character is the one that was bounced back by the server. Right? One comes back twice. It only appears once in the console on the IDE, and so on. That's all it does. So that just proves that I have connection between my computer to the Arduino via the network this time. So the connection is not direct. In the next demo, demo 2, we're going to take this sketch further. So we're going to make a modification that allows us to send commands to the telnet server running on the Arduino, and those commands will result to things like LEDs lighting on and off, or taking measurements from a sensor on the Arduino and returning that information back to us. Just a bit more a realistic example of the use of a connection like this.